Hello, welcome to the genuinely approachable Sudoku for the 19th of February 2024. It is Multiples by Philip Newman. So let's look at the rules of the puzzle. Normal Sudoku rules apply, so place the digits 1 to 9 in every row, every column, and every 3x3 box. Killer cages means digits in cages, cannot repeat, and must sum to the total given. So for example, those two digits sum to 9, those two digits sum to 12, and I was gonna say, right, because there are a lot of 9s and 12 cages in the grid. Actually every cage is, sorry, let me look at this properly. Yeah, every cage is summing to a multiple of 3. Okay, so that's the gimmick here. Ratio pairs, digits in cells separated by a black dot, so those two cells for example, must have a ratio of 2 to 1, so one digit is double the other. For example, 3 and 6 would work here, something like 2 and 4 would work here. No negative constraints, so other pairs of adjacent digits may have a ratio of 2 to 1, so those digits for example can have a ratio 2 to 1 if they want to be. Alright, so those are rules. With that, let us begin solving. And yeah, I definitely want to look at the clues, at the cages with dots completely inside them first, because what the dots mean is that one digit is double the other. So say the smaller digit is an x, the bigger digit will be 2x, and the total sum would be 3x. Therefore, we can say for each cage we know what x is, because this is 3 times something. This 3 therefore means that x is 1, and 2x is therefore 2, so that we know that 1 and 2 have to be in this cage. We also know that by just normal killer Sudoku where 3 can only have 1 and 2 in them, but for other cages such as this 9, we therefore know that it must be 3 with 6. For the 6 it must be 2 with 4, and so on for basically the rest of the grid. This 6 would be 2, 4, this 9 will be 3, 6, this 12 would be 4 and 8. Yeah, and there you go. Right, so we can do those digits, I think. Yes, in fact the 3 here just has to be 1, 2, which is resolvable by this 2, 4 pair. That has to be 1, that has to be 2. The 1 here means that's 2, so that's 4. We could do the same thing here, I think. Yeah, where if this was 2, 4 going up, then this has to be 8. If this was 4, 2 going down, then this has to be 1. So this is either 1 or 8. But because of the 12 cage, it can't be just 1, because the other digit would have to be 11, which isn't possible. So it must be 8, which is next to 4 to make 12. Yeah. 15 could be 6, 9 or 7, 8. Same with this 15. Oh, this 6 I think. Yeah, this 1, 2 here means that this digit has to be 4, I believe. Yeah, in fact 1 can't be in the middle, otherwise you'd have to have 2 on both sides. So 2 goes here, 1 goes here, this must be 4, which is next to 2. We could probably do the same here, I think. Yeah, this has to be 2 again, because 6 is either made with 1, 5 or 2, 4. This can't be a 5 because 5 has no pair here. In fact, 1, 2 and 5 all don't have any possible options here to make a ratio 1 to 2, so this must just be 2, which is next to 4. This 2 must therefore be next to 4, which is next to 8, which gives us a bunch of digits. 4 in this box, right, because of the 4s outside, have to be here, which is next to 5. So that's our first kind of interesting digit, I guess, which tells us what? No real idea. Well, this 4 resolves this 2, 4 pair. I guess this 8 also resolved that, because 2 can't be next to 8. So awesome. 2s, yes, 2s must be in the 9 cage here in this box. In fact, this 2 means 2 just goes there, which is next to 7. Next is 7. Right, what's next? 12. Well, we know 12 is made in 3 possible ways. It's either 4, 8, 5, 7, or 3, 9. Right, but because of this 5 here, you can't have 5, 7, and because of the 4, 8 here, this can't be 4, 8 either, so this must just be 3 and 9, which means that can't be 3, that's 6, that's 3. The last two digits are 7 and 8. So that's great. We can't resolve that, so unfortunate. What about other stuff like this maybe? No, I think this could still be, yeah, this could still be 3-9 or 7-5. We haven't figured that out yet. So yeah, maybe we look at, yeah, where does 4 go in this box? 4 must go here. Which should give us all the 4s, I think. All the 4s except the middle one, which must be just over, sorry, over here, which is next to 5 to make the 9. Same here. Right, so now this can't be, this can't now be 5-7 and must therefore be 3-9. Therefore this is 6, that's 3. Well, 3, 6, yeah, we have roping actually. 3, 6, and 9 can't be in those cells, so they must be in here. We don't know the order, but we know they are there. Therefore, 8 can't be in those cells, 8 must be here, which resolves the 7-8 pair. This 8 also means 1 goes there to make 9. The remaining digits are 1, 2, and 7. Right, and because those sum to 9, they can only be 2 and 7. So 1 goes here, which is 6 to 8. And yeah, an interesting fact about these 3 rows here is we have roping, which is saying that, you know, we have these 3 little sections here that are the same color. We have these 3 sections here that are the same, well, same number, I guess. And same here. So without even doing much work, we can just say, well, that this digit is a 5. I guess you can also say because of the 5 here, none of those digits can be 5. But we know those digits are therefore 1, 2, and 7. Again, because those sum to 9, they have to be 2 and 7. So 1 goes there. Ones are in this box somewhere. Well, where does 1 go in this box? 1s can't be in the 12 cage because the other digit will have to be 11, so 1 has to go here. Which means that 1 is in one of those cells. And therefore, looking at this box, where does 1 go now? The 1s, look at all, and say that 1 has to go there. Right, and then 1 is in one of those cells as well. Well, in fact, this is a 6 cage, which has to be 1, 5. There you go, because it can't be 2 and 4. So it must be 1, 5. This one resolves that. So 5 goes here, 1 goes here. This resolves the 1 down there. And we are actually cooking with gas. We need 5, 6, and 9. 6 over here means 6 has to be here in this box. This has to be a 5, 9 pair, which gives us the last digit in this column over here, which I think is a 7. Yeah, this 3, 9 means this is 3 or 9. Right, but because of this 3 here, this is 9, that's 3, that's 9. Those digits are 3, 6, and 8 to finish the box. That can't be 3. And I think that also forms a pair because of the 3, 6 pair here. We have 8 and 9 in these boxes. Sorry, cells. 8 means that's 9, therefore that's 8. Right, this 8 means this can only be made of 6 and 9 because 15 can only be made of 7, 8, or 6, 9, and this 8 here means it can't be 7, 8. So that digit is 6, that digit is 9, owing to this 9 over here. This digit must therefore be 8. Gives us a 3, 6 pair. In this box we need 3, 5, and 6. Actually, that digit, sorry, not 6, this 6 resolves this 3, 6 pair. I don't know what I'm saying, but that digit is a naked single, it's a 7, therefore that's 5. Those digits are 6, 7, and 8. 6 and 8 come here, so that's 7. Sorry, whoa, what am I doing? That's 7. This forms a 6, 8 pair. Don't know if we can resolve that yet. I don't think so. Okay, what about those digits? Sorry, no, let's look at here first. This 6, 9 means that's 3. So none of those cells are 3, which doesn't do much, but okay. Those digits are 5, 6, and 9. This can't be 6 or 9, so it's 5, which must be next to 7 to make a 12. This 7 resolves this 2, 7 pair. Awesome. 5 here means 5, well, 5 isn't there at all, which makes sense. Right. Those digits form a triple of 3, 6, and 9. This can't be 6, so that's 3 and 9. There should be something here. 15 maybe. No, I don't see it. Yeah, I don't see it. I don't know, sorry, that digit is a 4. Wait, no it isn't. It's a 5 to finish the column, which resolves this 5, 9 pair. Which, what does it do? Well, that digit must now be a 7 to finish the row, which means that digit is an 8. and this unlocks everything. 6 means that 9, which resolves, is 3 9 pair. 7 here resolves as 2 7 pair. This is 3 or 6, and this 6 here resolves that, so that's 3 6 3 9 6, resolving this final 6 9 pair. Nice. Solving the puzzle in exactly 9 minutes. Nice. Well, I hope you enjoyed that puzzle. I'll see you next time. Bye bye.